Welcome to this explainer. Okay, listen, if you're currently doing IT support for Mac users and you're still relying entirely on those graphical preference panes, you are absolutely going to want to pay close attention today. We're building a seriously powerful diagnostic toolkit, stepping completely out of the menus and right into the macOS terminal. It's going to fundamentally change how you diagnose and resolve issues. So let's just dive right in.
Check out this number right here, 120. To put that into perspective, a recent Nielsen-Norman Group study actually found that navigating your typical GUI preference pane takes an average of 9.3 seconds. And get this, it comes with a 22% error rate, just from people misclicking misaligned toggles or getting lost in confusing menus. But in stark contrast, a single terminal command, that executes in 120 milliseconds or less. That is exactly the kind of massive efficiency upgrade we're unlocking today.
So here is our roadmap for today's explainer. 1. Why the terminal wins. 2. Network diagnostic commands. 3. Processes and open connections. 4. System logs and storage. And finally 5. A real-world support scenario.
All right, Section 1. Why the terminal wins. Speed, precision, and auditability.
The divide between these two approaches is just night and day. You know, the graphical interface introduces so much friction and instability. It leaves these residual daemon processes running in the background, and it can mess with non-persistent keys that just end up breaking the next time there's a macOS update. But the terminal? It gives you direct, repeatable, pinpoint access to macOS's Unix core. Your commands are idempotent, meaning you run them and you get the exact same reliable result every single time. Plus, you can version control the whole shebang in your scripts. Moving right along to Section 2, Network Diagnostic Commands. We're looking at ping, traceroute, dig, and netstat. Okay, so our first layer of troubleshooting starts exactly where pretty much every user complaint begins, right? Network connectivity. The ping command is your absolute baseline. It sends a tiny little packet to a destination just to confirm, hey, can my Mac actually talk to this address? But a pro tip here, don't just look to see if it responds. Actually watch that time metric to monitor the packet response time for latency, or keep your eyes peeled for dropped sequence numbers, which obviously means packet loss. Let's step it up to traceroute and see how this builds on ping. Say a ping fails entirely, or maybe it's just agonizingly slow. Well, traceroute shows you the exact path your packets are taking. It reveals every single router, or hop, between the Mac and the server. By looking at this output, you can pinpoint the specific network appliance where things are falling apart. Is it the local Wi-Fi router, or maybe an ISP gateway 100 miles away? This tells you. Now, what if the IP address works totally fine, but the domain name doesn't? Classic DNS issue. Enter the dig command. This is the modern standard, guys. It completely replaces that old deprecated NS lookup tool. With dig, you can query name servers, mail exchange records, or actually, my favorite, use the +short flag for just a super clean IP output. You can even query a specific external DNS server directly, like say Google's or Cloudflare's, which is incredibly handy for bypassing a local ISP resolver that's acting up. To cap off the network layer, we've got netstat. Paired with a grep or egrep command, just to, filter out the massive wall of text you'd get otherwise, netstat-NA gives you this brilliant summary of active sockets. It pulls back the curtain and reveals exactly what the Mac is communicating with behind the scenes. Like find a rogue service listening on port 445? This is the command that makes the invisible suddenly very visible. Let's shift gears to Section 3, Processes and Open Connections. We'll be focusing on tips, LSOF, and top. All right, moving from the network over to the application layer, we really need to inspect what's actively running on the machine. Now, I know a lot of IT pros just reflexively use the classic PSAUX to find a running app, but honestly, using PS-XAO with these specific flags gives you a much better, more detailed cross-section. Crucially, it lists the PPID, the parent process ID. This is a game changer for tracing those rogue, resource-hogging child processes right back to the specific parent application that spawned them. Okay, so what happens when a user complains an app won't start because its network port is already in use? You use LSF, which stands for List Open Files. If you type LSF-I followed by a port number, boom, it instantly reveals which application, and the exact process ID is hugging that specific port. From there, you just terminate the process, and the user is back to work in seconds. The top command is an old friend to any Unix user, right? It's a great real-time monitor.
But the default sorting is, well, it's not always super helpful. By adding the O flag, you dynamically sort the chaos. Running top O CPU instantly bubbles the biggest processor hogs right to the top of your terminal. Or flip it around. Top OR size sorts by resident memory size. That's how you instantly catch an app that's suffering from a massive memory leak and just starving the whole system of RAM.
But wait, what about modern hardware? On the newer Apple Silicon Macs, the M1, M2, M3 series, the traditional top command doesn't really show the whole picture when it comes to efficiency cores versus performance cores. So modern engineers are turning to specialized command line tools like MacTop or ACTop. These tools analyze the unified memory pool, track specific core loads, and even monitor thermal states. It gives you unparalleled visibility into Apple's custom silicon.
Next up, Section 4, System Logs and Storage, highlighting log, disk util, and uptime. To truly round out our toolkit, we absolutely need historical data. macOS completely ditched those older text-based syslog files in favor of the structured, binary Apple unified log. Because of this, mastering the log show command is pretty much mandatory now for deep forensic debugging. You can pull the last hour of system events to see exactly why a kernel panic happened or why a background service crashed, all while completely bypassing the clunky console app. Let's talk storage. While commands like df-h are awesome for a quick glance at free space, disk util is your true heavyweight replacement for the disk utility application. It grants you the power to list hidden partitions like the EFI or recovery volumes that the GUI literally hides from you. You can even run a full repair volume command straight from the shell if a user's file system starts acting up. A quick uptime command is really a secret weapon. Sure, it's great for catching a user who is, let's say, stretching the truth about having just restarted their Mac. But the real treasure here is the load averages. These numbers show you how many processes were waiting to run over the last 1, 5, and 15 minutes. It gives you this fantastic historical context of exactly how bogged down the CPU has been. Context that a real-time monitor simply can't give you. Okay, let's put it all together. Section 5, a real-world support scenario. We have literally all seen this exact ticket, right? I cannot reach our internal company portal. It's extremely urgent. Now, we both know that blindly clicking through system settings menus isn't going to isolate the root cause fast enough, but with our new toolkit, we have a structured, surgical approach. Let's see how this actually plays out live. The key here is eliminating variables sequentially. Step 1, you hit them with a dig command live on their machine. Does the internal portal's name actually translate to an IP address? If no, boom, their DNS settings are wrong. If it does resolve, we move to step 2. You use ping and then traceroute to ensure the local network is actually successfully routing traffic to that specific server. Is a VPN dropping the packet somewhere? Traceroute is going to tell you exactly where. But what if the network path is perfectly clear? Well, the issue has to be on the Mac itself. Step 3, jump into netstat or lsof-i. Check if the required local ports are blocked or hijacked by some dead application process. And finally, step 4, if the ports are totally clear, run uptime and query the unified log with log show. You might find that a massive memory load caused a silent system crash in the background an hour ago. This quote really hits the nail on the head. By stacking these specific commands logically, you transition from blindly guessing at symptoms based on a user's vague description to surgically identifying the exact failure point in seconds. You are wielding the true underlying power of macOS. So you now possess the ultimate macOS diagnostic toolkit. By mastering these 10 core command line utilities, you're not just saving a few mouse clicks, you're fundamentally elevating the speed and precision of your entire IT support workflow. So here's my final question for you. Which of these commands are you going to fire up first on your very next support ticket? Thank you so much for joining me in this explainer, and hey, happy troubleshooting.